Okay, Assalamualaikum warahmatullahi wabarakatuh. We're gonna go with chapter 3 today based on this one, atomic structure. Alright, on chapter. Basically, outline of the course, you will be introduced with electromagnetic wave and radiation. This is I'm not going to touch into deep because you learn it in physics. And then quantum theory on Bohr theory of hydrogen atom and Rydberg equation. Quantum mechanics, and quantum number, NL, ML, and also MS. And then Pauli exclusion, Hans rule, and Ahbar rule. We're going to emphasize on this. And then atomic orbital and electron configuration, also paramagnetism, and also dimagnetism. Right, upon completion, this course student will be able to solve problem using Rydberg equation, determine the quantum number for orbital and explain meaning of orbital, right, and draw and write orbital diagram. So basically what most important is the Rydberg equation. That's why wavelength and those things are not important. Just you need to know the formula and then determine the quantum number. Determine the meaning of orbital system and able to write diagram of electronic. So we learned in the previous chapter on subatomic particle. It does has proton, neutron, and electron. And then also learn about the atomic symbol, how the element symbol, for example K for sodium, atomic number and mass number, what is the difference between these two. We also learned that already, and also isotopes. Alright, so this is on electromagnetic energy. You can see what's the most important value is here. See, speed of light is 2.9979 10 power of 8. Right, and then wave or oscillation. Okay, this is the wave of oscillation. Right, what is wavelength? So this is, you might need to know the meaning, what is frequency, and then how we measure frequency by unit of hertz. Okay, unit of hertz, cycle per second. 1 cycle per second is equal to second per second. Yeah, so speed of light, this is the fixed fixed value, 3 times power of 8 or 299 just now. Okay, so related formula, C is equal to lambda V. Okay, V is a frequency, lambda is the wavelength. Okay, C is the speed of light. So yes, that's the difference between amplitude, and these are example how to calculate frequency. For example, so we use the same formula, C is equal to lambda V, or you might rearrange the equation. Wavelength now is equal to frequency is equal to lambda over wavelength. Alright, so that will be speed of light 2.99 10 power of 8, or 3.0 10 power of 8 over 650 of the wavelength. So that might give you, unit will be in second, okay, per second, and then you may convert into hertz. Okay, so 4.61 10 power of 14 per second is equal to. Another problem, it says that wavelength is given, what is the frequency. Again, use the same formula, speed of light is equal to wavelength times by frequency. So rearrange the equation. You want the frequency as a main item, so you put C, V is equal to C over lambda. So you got this one. This is a straight calculation. Okay, so you may do this as well. All right, this exercise, you need to know our light is actually has been divided into few regions according to the wavelength of the radiation. So we have, this is visible wavelength of us, that where we see the colors, okay, where we see all the color that we have in front of our eyes, like red, orange, yellow, green, blue, indigo, and violet. So this is between 400 nanometer towards 700 nanometer. Less than that, we call it as ultraviolet, X-ray, and gamma ray, where we can't see by our naked eyes, but we have to use the instrument. And also infrared with microwave radar is more than 700 nanometer, and also radio wave. So this is mostly we can't see by our naked eyes as well, but we can hear it. For example, television wave or radio wave. Right. So invisible light cannot be seen by naked eyes. This is all invisible light. Okay, this is all invisible light at this region and this region. Alright. Okay, so visible light only occur at this part. Okay, we are lucky to see around this part, and those are very small. For example, infrared around 1000 nanometer. Okay, this is 1 millimeter, 1 meter, 1 kilometer. So we just can hear at this part, but we can't see it. So this one also we can't see it by our naked. Alright. So frequency is a part of energy. So we can say that frequency is a part of energy by using this formula. Energy is equal to lambda h, or this is actually Planck constant, where the value is 6.6 to the 10 power of negative 34 joule second. There's a fixed value. Balmer will start with 2 and N2 will be 3, for example. So RH, please remember the value 109.678 per centimeter, and then this is a Rydberg constant. Wavelength N1 and N2 is whole number integer from 1 to infinity, where N2 normally bigger than N1. If N1 is 1, thus N2 is equal to 2, 3, 4. It means it's bigger than that. Okay? Right. Okay, so we have Balmer. So Balmer series is start from 2. So the rest will be transition is be given now, N2 is equal to 6 down to N1 is equal to 2. So it means it start from 2, 3, 3, 4, 5, 6. 3, 4, 5, 6. Alright, so this one, the formula 1 over lambda is equal to RH. 1 over N1 is equal to 2, and 2 is given to 6 power of 2. So RH, we know the RH value, so you just convert it to 1 over 4 times 1 over 36. Get down the value here. Okay. So that will be give you 1 over lambda. So we want lambda. Lambda will be 1 over the value. So that's give the value in centimeter. So you have to convert in nanometer. Okay. So centimeter, 1 centimeter is equal to 100. 1 meter is equal to 100 centimeters. So we divide by 100 centimeter, we cancel out. So 1 meter to nanometer, we divide by 1 times power of minus 9. So that will be cancelled out as well. So that you got 410.3 nanometer. So this is a violet line, the spectrum. We have to check with the line. Okay. Now it's your turn to do this calculation. Right. Okay. When it says that it falls, okay, what is the wavelength of light that is emitted when an excited electron of hydrogen fall from N5 to N3? So this should be N1, this should be N2, because N2 always bigger than N1, right? So that will give you, right, we go with Bohr theory of hydrogen atom. Bohr is the next theory that has been proposed by scientists on hydrogen atom. The first theoretical model successfully accounts for Rydberg equation, where it has quantization of energy in hydrogen atom and correctly explained the atomic line. The purpose that says that electrons move around the nucleus like planets move around the sun, so move in path and or orbit, and each orbit has fixed. And then come in 1913, Niels Bohr has proposed this one. It says that electron exists in series of shells and has specific energy level. So it means that, just imagine that it says that everyone have their own room and they have their own specific level. So they orbit the nucleus much like the way planet orbit the sun. The energy of electron are quantized. The energy of electron is given shell. And then he proposed this formula, En is equal to minus RH over 1 over times by 1 over So most information is come from the excited state, where we have the ground state and then we have the electron that jump up or excited to the excited state. So electron absorb energy, it move to higher energy to excite the state, and from that electron also have study on light emission, where electron lost the photon of the light, drop back to the lower ground state here. So what goes up goes down back. So this is the theory of. Okay. Then we'll now going to learn about quantum numbers and atomic orbital. Atomic orbital is specified by 4 quantum numbers, which is n, l, m, and also s. Okay, so n is a principal quantum number, it's positive integer. L is angular momentum quantum number, and it has an integer from 0 to n minus 1. L is the magnetic moment of quantum number. It's flat back to here, but it has magnetic moment of this one. For example, from -1 to positive 1. And then 3 quantum number are required to describe the distribution of electron in hydrogen atom. Then we have the spin, electron spin. Either the spin is upwards or downwards. Okay. So n is a principal quantum number, is referred to energy level. L is azimuth or angular momentum, is referred to the shape of the orbital. Alright, and then m is the magnetic, is a orbital orientation in the space. S is the electron spin, the direction of electron spin, clockwise or anti-clockwise. The higher value of n, higher shell, and describe the course of energy and size of electron orbital, relate to average distance of electron from nucleus. Yes, this is mean you are far from nucleus compared to number 1. Okay, angular momentum or L, this is azimuth or angular. Symbol is L, is specific of the subshell of an atom. Okay, value can be calculated from n minus n up to n minus 1. For example, if n from number 1 just now, from quantum n just now, is equal to 1, so L is equal 1 minus 1 is equal to 0. Is n equal to 2, L is equal to 2 minus 2, then 2 minus 1, so the value would be 0 and 1. Okay, alright, so this one, if n equal to 3, so you have to do 3 times. L is equal to 3 minus 3, 3 minus 2, 3 minus 1. So LU will be 0, 1, 2. So you have to do this n minus 1 each time if you have number n. Okay? Right. P is 1, D is 2. Okay? And then F is 3, and so on. Okay? Okay, for quantum M describe the orientation, okay, of that one. Is it positive or negative? For example, when L equal to 1, M would be -1, 0, +1. If you get 2, so -2, -1, 0, +1, +2. So it depends on L. L is depend on N. It degenerate the orbitals. Okay, each component are represented by subscripts of this one. Okay. So this is example for L. L is 1, so you have -1, 0, and +1. So means that the shape, it has -1. This is the shape of -1. This is the shape of 0, where it's on Y. Okay, the orbital sit on the axis of Y, while we have ML is equal to +1. The axis B on the straight of PZ. Okay. Yes, it describe the shape. Okay, for MS, it describe the spin. Spin either just has 2 spin, positive half or minus half. The spin is clockwise direction or anti-clockwise direction. Okay. So this is example of spin. If it has positive spin, it's point out to the north. If you have from south to the north, alright. So if you have MS from south to the north back, but the spin is anti-clockwise, so it just spin up like that. Anti-clockwise. This is clockwise spin. Okay. Right. So relationship. Each shell can be filled by 2 n2 electron, and each subshell can be filled by 2 times 2l plus 1 electron. For example, this one. n equal to 4, so it filled by 2 times 4, 2, so you have 32 electrons. So such shell will be filled by 2 times 2, 0, 2 times 2, 1 plus 1, 2 times 2, 2, 2 times 2, 3 plus 1. So this is a subshell. 24, 30, 32 electrons. So if such shell, because we have 4, such shell number 4, it has 4s, 4p, 4d, 4f. So how many electrons can be filled in? So this is how we calculate it. For s, s is 0, so 0, 2 times power of 0, 2 times 1, to p into d is 2, for f is 3. Okay, let's stop here first.